Hello grade 12s, welcome to my channel. Let us just do some more work. Unfortunately guys, I couldn't make it to class last night, so I hope you guys are going to forgive the tutor. Anyway, as a token of what you call that one, I'm going to do these questions for you guys, and just to make up for the time we've lost, so that at least we keep the lights on. They must never fade. Okay, right, so we're going to take these mixed problems to see exactly how well you should perform in these. This is very good for those who are going to write the May June exams. This is also good for grade 12s in the term 2 exams, term 3 exams, and term 4 exams. Even grade 11s can learn a thing or two, because these are problems that essentially would qualify as strictly higher grade for grade 11s, but for grade 12s it may be a mix of standard and higher grade. So now let's just deal with this question 8. Now we're going to start with 8.1. Okay guys, you must have practiced this. I shared this document in the group. So those of you who are in our WhatsApp group, just go and check on the documents shared in the group and keep a copy for yourself. Please guys, take nothing for granted, I beg you. So this is a simultaneous equation, but one that is essentially just one single equation. Now we need to be very strategic to get solutions into these problems. And again, it takes a lot of patience with these problems, because if you give up too soon and you want to see a memo, you will never learn. Sometimes you've got to struggle, not know what the answer is, maybe spin your head the whole day and then the next, until you figure it out. Don't give up just because you want a quick answer. Those kinds of students don't succeed. But those that struggle and enjoy that struggle to some extent, and of course later fully enjoy their success when they finally figure it out. If it doesn't send you to some form of research, then you just should know that during that sitting or practice session, you're just bluffing. You're not doing anything. When you're practicing, you should find yourself challenged. Don't, no matter how tempting it is, do not go and look up solutions. Try it until you find it. Then, if a week ends, you do not have a plan, then go and seek for help, okay? And I'm here. Okay, so folks, we're supposed to solve for x in terms of y. So that's the instruction. Solve for x in terms of y. And there's a restriction that x is not to be y. So this means there's a chance that within this manipulation we're about to do, we are going to find x to be equal to y. We need to reject that solution. Okay, so let's see what we're going to do. Of course, folks, once we see brackets, we know the three-step approach. We do BODMAS. We deal with brackets first. So we FOIL. So this is going to be x squared minus 2x minus 3 equals, this is similar, it's just going to be y squared minus 2y minus 3. Now folks, in grade 12 you don't need to be shown how to FOIL brackets like in grade 10. No. Your brain should be, trust me guys, if you are not able to do this effortlessly as I'm showing you, just remember you're going to have a problem with maths. You're going to struggle. So unfortunately, it is what it is, guys. So this is of the same sign on either side. We, in any case, are going to have to move things around. Now we've got two terms. We don't have a product, so we cannot say this looks like that, because the variables are totally different. So what is best when we solve quadratics, remember this is a quadratic. The highest exponent is 2. So we just write it in standard form to some extent. X squared minus 2x. This time we're going to say minus y squared minus 2y equal to 0. In fact, I could have just easily moved these terms individually. So this is going to be minus y squared plus 2y equal to 0. Now remember guys, every time you get to a particular step, it's not always going to be too easy to tell where you're going to go. So don't get too used by lower grade questions where you can already see from every step that another step is just going to follow religiously. Sometimes with these kinds of problems, you have to keep your eyes opened. What do I see now? Because you see, there's a mixed masala here. If you take the highest common factor with the x's and take the highest common factor with the y's, you're going to end up with a bracket that has x and some number and a y and some number. Now those brackets are never going to be the same, so it's not going to take you anywhere, but do think about it. There are some problems that can do that. So grouping and mixing and nothing is going to work, but one thing should strike your mind, that x squared and y squared, this is a difference of 2 squares. So technically grouping is not necessarily out, but you need to be smart about it. So if you always observe and look, you'll always find a way. Right, so and we can already see immediately now that there is a common factor here between those two terms. We know that 2 is the highest common factor there. So this means if we can group these like that, we stand a chance of getting somewhere. So x squared minus y squared, we group them. Then we take this original sign and we write these inside. So this is going to be 2x. Now if we took the negative out, we are literally factorizing. So this means this negative must go as well. So that positive must go. We're going to get 2y equal to 0. So I hope you can see what's happening right now. We're already winning. This is a grade 10 technique, by the way, of factorizing by grouping. Now we know that a difference of 2 squares can be factorized by conjugates. So this is x minus y, x plus y. So we've now factorized that. And here we can take out the highest common factor, which is 2. And then what do we get? We get x minus y. Okay, so that's fine, and this is equal to 0. Now what do we notice, guys? We notice that, oh well, this bracket is common in these two complex terms. Now we further factorize by taking out the highest common factor, which is going to be x minus y, and what remains is going to be x plus y minus 2 equal to 0. Now you can already see that this bracket was discouraged, because now once we've got a product and we've got 0 on the other side, we can easily say this should imply that x is equal to y when we solve that bracket. But remember, we were told, so we know that this is not allowed. Or we can easily say x plus y minus 2 is equal to 0. So we can make a conclusion that x is going to be, with transpose, it's going to be 2 minus y. Now this is solved because we were asked to solve for x in terms of y, such that this is discouraged. So can you see, guys, some questions are not so smooth. You don't know what is next from the outset. You have to move into that step and think for a moment, observe for a moment, make up your mind, make a decision. Now these basic ideas of difference of 2 squares, sum of 2 squares, and all these factorizations by grouping, factorizations by highest common factor, you know, the inspection, bracket method, long division, you name all of these techniques. They are taught so that when you see these problems, you make up your mind as to what you're going to do. Because this is always going to be required, but you're not going to be told from, you know, straight up. Yes, there are some lower grade questions where, you know, from looking at the expression, what is going to be the next step, and everything follows from there to the answer. But here, strategy is key, guys. So these are higher grade questions. As you can see, it's a level 3, so you cannot just come here and think you're going to chill. All right, folks, so how do we score the 5 marks? Obviously the answer is a mark. This factorization is a mark. Our difference of 2 squares is a mark. Of course, we can say taking out the highest common factor here is essentially being marked in this step at the bottom. So that's 3 marks. We can say, well, grouping was setting up the mood, essentially. We can say for our troubles to deal with those brackets. Whether you give it there or you give it here, it's up to you guys. At the end of the day, 5 marks is in the bag. And as you can see, I'm not just marking randomly. There is an informed decision on why a mark is to be considered for that particular step. As I told you guys that the 3-step approach where you've got BODMAS, you may not get a mark there, except when you use those steps in application. But sometimes we may feel that for you to even think about doing it was not so obvious if it's going to take you anywhere, then it can give you a mark, okay? But every time you factorize, every time you use some law, some rule, perhaps logic, you always get given a mark, okay? Anyway, folks, that was 8.1. I hope you guys have learned something. So these are not very easy questions. You need to be very, very, very strategic. Otherwise, you can lose your way easily. So I hope this becomes a way of getting into the groove of solving complex problems with simple ideas, but in a strategic way. Now here we need to solve for x again in terms of y. See, similar story. So we're given 3 to the exponent x plus 2y, right? This is giving us 3 to the exponent 3y, all divided by 27. Okay, no problem. So what do we do? First, take a moment. Don't rush. Take a moment. What do you see? I'm seeing a power of base 3. Can 27 as well as 9 be expressed as a power of base 3? The answer is yes. So let's try with that first using our exponential rule. So this is going to be x plus 2y. We can already see that exponent defines x in terms of y, literally. Now let's have a look at this one. This is 3 squared. Please show these steps. There's no need to rush here. So this is 3 cubed. If you don't know these, you take these whole numbers, you press on the calculator that number, you press an equal sign and say shift fact. But remember, if you cannot do that with small numbers already, your maths game is poor, right? So don't do it. Try to get that brain working. Otherwise, you will never see where maths is going, no matter how hard you do it. Of course, we've got 3 to the exponent x plus 2y equals. Now we know that once we divide powers with the same base, we literally can move the power in the denominator into the numerator such that we multiply powers with the same base, then we add the exponents. But since this was in the denominator, it becomes a negative exponent in the numerator, and as a result, we just simply subtract the exponent from the exponent of the other one. But we need to first sort that bracket. So again, when we've got a power raised to a particular exponent, only the exponents multiply. So this is 3 to the exponent 6y, because 2 times 3 is going to be 6, and then y. And then, of course, we are going to then subtract the exponent at the bottom by using that law. So I'm just trying to do 2 things at once. Remember, with exponential rules, there's too many areas because the laws keep applying most of the time in those expressions. So you end up not knowing what is important. So when you can handle it, just do it, okay? So let's move on. Now we've got 3 to the exponent x plus 2y equals, then 3, I don't know why I did this. I should not be doing it again. Now, folks, again, as I said, we always look before we proceed. As you can see, the mistakes that keep happening end up repeating yourself. Now we've got powers of the same base that are equal. So it means the exponents must also be the same. So it means x plus 2y should be equal to 6y minus 3 using that law. So this means our x is going to be 6y minus 2y is going to be 4y minus 3. Technically, that's the one. We can actually make this a conclusion. Remember, in grade 12, we try to be as straight to the point as possible while taking care not to make unnecessary mistakes. And if at all you are erratic, rather show all the steps until the end. Now, what do we do, folks? When we use our exponential rules here, converting those whole numbers into their prime bases, that's a rule, and in fact, it's significant here. And for our troubles for this expression, obviously, multiplying the bracket and moving the expression in the denominator up, this is good. And this is significant when we use the ultimate rule where we say if powers are equal and they are of the same base, it means the exponents are also equal. That's just a logical deduction. Now, folks, we were getting only 3 marks. Are you kidding me? Okay. It's all right. You can say that. That's fair enough. And of course, the answer is the ultimate. There's no way we wouldn't give it a mark. Okay. Again, folks, not a very difficult question. It's a level 2. It's a bit tricky, but not so bad. Okay. So we're going to keep drilling these until you guys are the masters. 8.3, we are told that k plus 5 equals 14 over k. K plus 5 equals 14 over k. Now, these rational equations are very interesting because you will learn to understand restrictions and, of course, domains and ranges in this case. Now, we need to solve for k. So, obviously, we write the expression again. Don't be lazy. Remember, we were just writing what was given at first. Now we are solving. So, this is over 1. So we know that, folks, cross multiplying is the easiest target, but cross multiplying is nothing special. It's just a simpler way of looking at multiplying throughout by the common denominator. So however you want to look at this, as long as you're going to get it right. So this is k into k plus 5 equals 14, right? Of course, I could easily have just done this and say k times k is k squared, but I'm just trying to be as systematic as possible so that you guys can learn a thing or two nicely. Of course, this is a quadratic expression, and we know we need to isolate 0 to solve nicely without problems. Now we can factorize this. Definitely we can. Most likely, it will be factorizable. So K14 has plus 7 and minus 2. Again, knowing how to factorize, guys, should be effortless in grade 12. So we know that K is a 2 or K is minus 7. Are these solutions all right? Please check these solutions before you sit with them. Now, what we check is that this thing must never be equal to 0. That's the first thing. Second thing, we need to check that the left-hand side is equal to the right-hand side. Because if that's not the case, then this doesn't work. Now, let's see. If we put a 2 where k is, we get 7, right? Then we put a 2 there, we get 7. So 7 is equal to 7. So this one passes the test. So this is good. And we can see that 2 in the denominator is already greater than 0. So 7 again, minus 7. So we're going to get here, minus 7 plus 5, that's minus 2. 14 divided by minus 7, that's minus 2. Again, the left-hand side equals the right-hand side. So this solution is good. But minus 7 is already not equal to 0. So that's perfect. Now we can safely present this to our examiner with a big smile, knowing that we behaved well. Please don't undermine the importance of checking. You are going to get caught nowadays. for just writing solutions that are incorrect. In fact, I want to say, I'm the first one to say it perhaps, I want to suggest that if any one of the people in the authorities in our education system, I need them to reintroduce negative marking so that we do not have people who just simply move along like papers in a windy day. We want people who are like trees who can hold on despite the storms and winds. This is what I'm trying to say, that if a student comes up with a disallowed answer, we should deduct a mark, or perhaps, maybe let's be fair, half a mark. There has to be a punishment for being silly, while at the same time there is going to be a punishment for not adhering to instructions. And at the same time, we want you guys to perform at your best. But you cannot come here and go through the motions and then claim you are a mathematics student. That is witchcraft. Right, how many marks was this? 3 marks. Obviously, folks, I suppose when we factorize was the key step. Remember, as I told you, issues of dealing with fractions, Bodmer style, we may not. So this is 3 marks, but at best you may perhaps be given a 4th mark, because I mean, we are not too mean, but we have the right to be if we choose. Right, hence or otherwise solve for x. Now can you see, this means the examiner is trying to help you here to see something. Then you have to make it look like that, because the moment you see that statement, hence or otherwise, meaning you are allowed to go to town, because some of you know what to do. But the examiner is trying to solve your pain here by suggesting that, look, could you use what you've done above to solve the problem? Perhaps. Now, we first write the expression. Don't rush. So this is x plus 5 equals 14 over the square root of x plus 5. Now just inspect, don't rush. What do you see? I see a 5. It's positive. Where did I see a positive 5? I saw a positive 5. Okay, there's a striking resemblance here. I also saw a 14. Now here's my 14. But now there was some strange dude, K, which I cannot really give a name, and there it is. But I also see a similar situation of what could be, this very strange thing. So I can already see that there's a very striking resemblance of this equation to the previous one. So how about I say let the square root of x plus 5 equal to k. In fact, try to name it what you already have above so that you can easily take those solutions. So this implies now that the square root of of x plus 5 is going to be k plus 5 equals 14 over k. Oh, well, this is indeed the same equation. From here, you can just easily say this implies that k is going to be 2 or k is going to be minus 7. Remember, these are from, you can even say C, A above. Remember, guys, pretend like the person who's going to mark your script is not a maths person and needs your guidance to really understand you and your logic, because this is what we are testing. We want your logic and to see what we have taught you has set nicely in your brain, and not just set there as some ornament or something, but it's actually a very useful part of the engine that we are building in you. Anyway, folks, so this implies that now we resubstitute, as you know we should do. So x plus 5 is equal to 2, or square root of x plus 5 is equal to minus 7. Now, always this is good. Now, if I can tell you, is it possible, guys, for a positive square root? Now, remember, with these kinds of problems, we don't assume the plus or minus thing, because we always assume the character of the square root. Can you see? In front of the square root, there's no sign. So this means it's positive. It's an invisible positive. We don't write it in front of an expression. If you look there again, it's an invisible positive. So there's no way a square root of a positive number, there's no way that a positive square root of a number, I don't know why this thing likes to do this. It's so sensitive lately. I cannot believe. There's no way that a positive square root can give us a negative number. Problem is this negative that makes us to say immediately, let us not waste our time, because we may be willing to, square this and square that and say, but it can work. Yes, it can, but there's no way logically that a positive square root of any number, provided that that number cannot be negative, because you know that for this to be real, what is under the square root cannot be negative. Okay, can either be 0 or positive. So there's no way we can get a negative number. So you don't want to waste your time with that solution, just solving something that's just going to give you invalid solutions. Now let's look at this one. We know what to do now. We take the square root as we know how. Can you see now we brought it down to a standard grade question now from grade 11. Now we do this. The square on both sides because we're solving for x, so we get x plus 5 equals 4, right? So therefore our x is going to be equal to minus 1. Now this should be the only answer, right? Now let's take it back and see that this original equation, first of all, what we want to make sure that that guy is not equal to 0. No, is not less than 0. Okay, yeah, let's say it's not less than and equal to 0. Can strike that, but now I don't know how to write this symbol nicely. I always have an issue. So let's just write it so that we can do the things that we want. So this must not be less than or equal to 0. Right? Because if that's the case, it means the denominator is going to be 0 and we cannot divide by 0. Secondly, we cannot take a square root of a negative number. That's the first thing we want to check. Second thing we want to check is that the left-hand side is equal to the right-hand side. Unfortunately, the checks here are mandatory. There's no way you can say, I will skip that step. Let's take minus 1. This is minus 1 plus 5. That gives us 4. Positive square root of 4 is 2. 14 divided by 2, 7. Same here, it's going to be 2 plus 5, that's 7. So 7 is equal to 7. So this is a good solution right there. And we were solving for x. Now, imagine if you worked on this one. Would it work? Let's just check for fun. Because sometimes it's easy to rubbish something and, I don't know why I'm doing this. Now, guys, I'm going to pretend I've already done this step. This is going to be x plus 5 equals 49. Right? Now, this is going to be x is equal to 44. Right? Now, let's check if this is going to work. 44 plus 5, that's 49, right? Then 49, square root of 49 is 7. 7 plus 5 is 12. Okay, we've got 12 in the left-hand side. Here we've got 2. Can you see 12 is not equal to 2? So this already fails the test, right? So this means we were correct to reject it immediately because it doesn't lead us to anything meaningful. Good stuff. So usually with these questions, this rejection is usually considered for a mark because it is important to not present that as a possible solution. If you do, it means you're a careless maths student and we should punish. So that's why we reward the rejection, because it is a necessary rejection. Okay. Fine, folks. And then this, substitution method of whatever you want to call it is key. So how many marks was this? 3 marks. And we have them nice and easy. As you can see, it's not too complex. But if you chose to struggle, you could. It's not a big deal. But there's no need. When someone simplifies your life, follow that, because they're trying to suggest that you would not have thought of such a plan. Hence, they're trying to help you out by giving you a much simpler way to get to the answer so that you can be economic. Okay, guys, hope you are learning as we keep going. Remember, this is not for me to impress you, but for me to give you ideas on how to go about business and be efficient at the same time. Right, so let's take this one. 8.4, we are told that if x minus 6 is equal to 0, it's one of the solutions. Now remember, when someone says if, it's not saying this is, it could be. We don't care if it is true or not. This is an if situation to suggest that this having been, remember in maths, don't be always hung on to the fact that the answer has to be true mathematically. It may not be true. But if the examiner is proposing something, the examiner is trying to check, are you able to follow an instruction? Because at this point, we don't care about your knowledge of maths per se for its correctness. We just want to see, could we drive a certain message and you follow that without questioning it, but trying to make everything make sense in this newly found environment that we are creating. Because maths is all about creativity. Right. Now, the reason why I'm talking about this is because I know this is definitely not a solution to this equation. It's not. But the examiner is proposing it. Now, could you be able to follow the proposal? It's like following the scientific method. Sometimes you want to postulate something. Then if you assume that your postulation is true, then what conclusions would you come down to? Right, it says now let's assume, or let's pretend, or perhaps let's accept that x minus 6 is one of the solutions. Now once you see that of the equation x plus 40 over x is equal to 16, now we can already see here that this is a quadratic equation, okay? Because if we cross multiply, we're going to get x squared minus 16x plus 40 equal to 0. So if that's the solution, it means this x minus 6 must be a factor, right? It must be a factor. Okay, now it says determine the value of y, but the one value of y for which this is the case. Again, as I said, try to explore what do you see. Now what I'm seeing is that I see a 16, I see a 16. I'm seeing a 40, I'm seeing a 40. Now already this guy looks like that guy. So this could be the guy and that guy. So take time and inspect. Trust me, inspection will save you time of so much trial and error. Although you may have to go through it, but it literally directs your paths. So how do we do this? Because now this is the main guy. So 2y plus 3 plus 40 over 2y plus 3 is equal to 16. We can safely say let 2y plus 3 be equal to x. We're going to choose specifically x because this is the equation we want to compare this to. So now what do we end up with? Such that we've got, instead of 2y plus 3, now we're going to have x plus 40 over x is equal to 16. We can say this implies that, now remember x represented y, so this implies that definitely x minus 6 is equal to 0 is, okay, let's just say that. We can just say this implies that x minus 6 is equal to 0, suggesting that this is the solution. Now let's go on. So this implies, what is x? X is 2y plus 3 minus 6 is equal to 0. This then implies that 2y is going to be 3 minus 6 is minus 3. We move it, it becomes 3. Therefore, y becomes 3 over 2. Nice and easy. Look, we don't care how true this is. Of course, if you solve this equation, you will know that you're going to get x squared minus 16x plus 40 equal to 0. You will already see that this cannot be factorized with this factor right there. But we follow what the proposal of the examiner says. We don't care about its truth or not, because here it says if. Now in maths, guys, when you're doing a proof or something that comes from some, idea or postulation or presumption, sometimes you just follow that law and you do the mathematical gymnastics the right way, but don't correct the examiner. Okay, don't say, but this question is wrong. No, it is wrong, yes, deliberately. But would you then come to some form of a conclusion despite that being wrong? Because you will find that in real life, sometimes you've got to be wrong deliberately to come to some certain conclusion, which may be necessary, by the way. Because if you are right, you will never come to a conclusion at all, or at least something that is meaningful. Now think of you. Okay, let me not give you this example. It's dangerous. But let me make it. I mean, this is not for small kids after all. I need to really pick your brains a bit. Now imagine you have a parent, mother and father. Now, perhaps these two are trying to neglect each other while they take good care of you as a child. Now, while you were walking somewhere or minding your own business or with your friends or whatever, you spot your father, with the woman in the neighbor's house. Question is, are you going to go and tell your mother, that your father is cheating on her with the neighbor's woman or whatever, neighbor's wife, or it could be just a woman in the neighborhood? Are you going to tell? The answer is, well, the right thing to do morally is to tell. But what are the consequences of that? They are going to divorce. And when they divorce, they're going to fight over you. And one of them is definitely going to use you as the weapon to get to the other person. Guess who's going to get excoriated by all this energy, which has nothing to do with them? It's you. You're going to lose your family. You're going to lose your mother. You're going to lose your father to some other woman and your mother to some other man, in which case when you need one of them, they won't be able to look after you, because if your mother remarries somebody else, that somebody else doesn't care about you, hates you, treats you bad. You go to your father, he has another woman. That woman doesn't love you, doesn't care for you, doesn't want you. You end up an unwanted child. And guess what? If you just pretended that, look, what if I didn't see anything? It means you wouldn't tell anything to your parent. And if you didn't tell anything, guess what? Families together, they pay for your school fees, you go to school, you come back, they pay for your university, you graduate, you come back to a family that is together. And guess what? Your father along the way would have realized that he's doing the wrong thing, and he decides to come back without your mother knowing what he was doing. At the end of the day, certain things may be wrong today, but tomorrow they might just be corrected, either by themselves or by some chance. But remember, there's always a chance for something to go in the right direction or in the desired direction. So do not rush to act when you see things. Study those things, learn from those things, examine those things, so that when you make a move, your move is calculated and is goal-directed, not something that is just blindly being arrived at. This is the situation that this question is trying to teach you, that at some point the truth doesn't land you anywhere. As you would know, if we decided that this is untrue, then you end up stuck not knowing what to do, and you're going to fail those 3 marks. But imagine if you're just someone who is, matured in the brain, looks at the situation, looks at it good, and decide according to that situation. And guess what? You stand on the other side as a winner. And what if what you saw was not even what you think it was? Because later on, after doing that, Later on, you discover that these two are siblings. They share the same father, but it was never told. So your mother didn't know that the woman in the neighborhood was actually your brother's sister, and you didn't know that. All you saw them hugging and talking, holding hands, but you didn't know that this was a love affair or what. Then you find out later that, oh well, they share a father but different mothers. You see these things. Now can you imagine the damage you would have caused, but for something that was not supposed to come out the way you brought it out? So watch out, guys. Don't be fools. Now I'm trying to make you guys the best that you can be, because I don't need you guys to be situational and consequential. I need you to be people who apply, the ethics of Immanuel Kant, deontology. When we talk about duty, when you look at things, see some duty in there. And remember, if you've got a sense of duty, you know that some things are not supposed to be done anything about, irrespective of how bad and how wrong or whatever you're going to look like if you are found to have kept this. Look, there's always a way out of every situation. But trust me, the way out must be the best way, not the dangerous way. Anyway, guys, let me not preach. Just wanted you guys to be aware that certain things are very important. I would perhaps give you a mark for this. And then, of course, I would give you a mark for this. And then the mark for the answer. How many marks was this? 3 marks. Of course, guys, one can decide to say, look, to let something, it's not a big deal, but perhaps here. And then to come down to, adopting that solution is good enough. But if we already substituted, we may not care about this. You may think about this or that actual substitution. But I think the actual substitution makes a bit of sense. And that's the solution, guys. Wrong or right, we don't care. We follow what the examiner told us. So follow the rules, guys. Don't make the rules. Okay. Right. 8.5. This is one of my favorite questions for students. Now it says calculate the maximum value of S if S is this situation. Now obviously, guys, if you are a smart student who understands quadratic equations, you would see that this is a smiling parabola. Now the smiling parabola has a minimum value at the turning point, right? Because this is the lowest point on this parabola. Now there's nothing you can do about the numerator because it is a constant. Now remember, for this to be a maximum, it means when the numerator is a constant, then the denominator must be as small as possible. As I taught you fractions in some of the videos, especially the one on higher grade algebra. And of course, many other instances where I was discussing this. So basically, this means we want this minimum. So what would be the minimum value here? It's obviously going to be 2. Why? Because x squared is a perfect square. So this is either 0 or greater than 0. But now we want it to be the smallest value it should be. So the smallest a perfect square can be is 0. So this leaves a 2. So essentially, the maximum value is going to be 6 over 2, which is 3. Very easy. That's why it's 2 marks. But you would be sweating here. All right, we say S is equal to 6 over x squared plus 2. Sometimes when I say S, I feel wrong, You know the S? Sometimes I feel like we should say C. C, C is equal to... But anyway, if we say C, then we're not making sense again, alphabetically. So we can just say the maximum... Okay, we can just say this implies that the maximum value of S is going to be equal to 6 over 2. You don't explain nothing, but of course, you just try to tell that this expression must carry the smallest value it can be. A perfect square can only be 0. And if you like, you might just want to show this a bit and say, fine, this is when the variable is 0, but I know it's not necessary. This is 0 plus 2 because 2 cannot be smaller than itself. It is what it is. As well as 6, it is what it is. But if we're saying everything must be as small as possible, 6 is the smallest, but x squared, the smallest value it can take is 0. Please, I know that we know there are integers here, but now we're looking at it in terms of it being a perfect square. A perfect square can only be 0 or a bigger value than 0. So what is the smallest value? 0. So we can say which is equal to 3. So this is very easy, guys. You get a mark for that and a mark for that. But again, you can use the knowledge of functions to navigate this question. Otherwise, as you can see, it's a very simple question, as long as you understand what's cooking. Next, we're supposed to find the two values of x over y. Okay, again, this is a level 3 question. Within the same equation, we've got two variables. It's a tsunami, right? Let's get to it. So this is x over y plus y over x. I think this one was a question that came out of, was it Mpumalanga trial? Or was it the Northwest? Or was it KZN? I think Mpumalanga. But anyway, it doesn't matter where it came from. We're going to solve it. Now, folks, what do we do here? You can already see here that when x multiplies that x, we get a quadratic. When y multiplies this y, we get a quadratic. So we can already see here that from inspection, we're going to end up with a quadratic expression. But this one is one that perhaps fits an ellipsoid of some sort, because it's going to be some xy term as well. So of course, guys, in this case, we multiply by the lowest common multiple, LCM. Please don't say LCD. All right? I need you guys to not say I need you guys not to say wrong things, okay? Now, what is our LCM here, guys? It's going to be 4xy. So basically, the lowest common multiple is when we multiply the actual denominators together. They will give us the lowest common multiple. That's the idea here. So this implies that when we multiply by 4xy, the y goes away, we get 4x squared. Plus, when we multiply by 4xy, the x goes, we end up with a 4y squared. Plus, then we're going to have 17, the 4 divides to 1, then we get 17xy. Sorry, this is equal to, can you see? Nice and dandy, nice and dandy. Now let's see, what can we do? We want to write this in the standard form, 4x squared minus 17xy plus 4y squared, because we want this to be a nice trinomial. Now, folks, we can decide that, look, it's easy to factorize something like this, because if the middle term has, a portion of that and a portion of that, it means this can be factorized. So let's see if we can. So if we say this is 4x, this is going to be x. And then we need to decide. We want this to give us 17. So we want the 4 to align with 4y so that we get 16. And then if we get that, we're going to just put y over there. Nice and dandy. So what are these signs? Both negative. Can you see? Nicely factorized. So we are winning. We are winning. So from here we know that x is going to be equal to, I think it's cool. You can say 4x is going to be equal to y, or x is going to be equal to 4y. Now when we divide by y on either side of the two equations and by 4, basically we divide by 4y here. So we end up with x over y equal to 1 over 4. Right? Or we're going to have x over y. This one is going to be equal to just 4. Right, so this is exactly how we solve this. Nice and easy. Now you can already see here, it's either you do the right thing or you don't, because we are going to have issues if we don't do this. Now, folks, you might want to say, okay, is it possible for me to check that these solutions actually hold? Well, it's easy. We can. We go back to the original expression. Now, the best thing we can check here is that the left-hand side equals the right-hand side. Because sometimes you're not sure if you're doing the right thing, especially if you see this for the first time. Now, let's have a look. X over y is a quarter. So we've got a quarter there. Plus, now y over x is this fraction inverted. So this is going to be 4 over 1. And then let's see if this is going to be 17 over 4 at all. Let's see. This is going to be 4 times 4. Just cross multiply. For those who know, they can quickly do this. Cross multiply and divide by the denominator as well. So this is going to be 4 by 4. This is 1 plus 16 over 4. So you just multiply these together like that. And then you're going to have 17 over 4. And guess what? 17 over 4 is equal to 17 over 4. So we know that, well, we are good. Is good is nice. Next one, you check the other solution as well. Let's see. What do we see there? X over y is 4. So we're going to put a 4 plus. When we invert this, it's going to be a quarter equal to 17 over 4. Again, we end up with the same thing that we did. So it's definitely going to be 17 over 4 equals 17 over 4. So nice and dandy. So you can already see that, okay, however ridiculous it looks, actually, it's correct what we did. And of course, we always get a mark for this. How many marks was this, by the way? 5. So obviously, folks, I think for our troubles to know that we need to multiply by that denominator is key. We can even award this standard form. Can you see, when the marks are enough, we can even think about writing that equation in standard form, because you wouldn't know by the way it looks, because not a nice simple quadratic, it's quite complex. But to now write it in standard form, still it shows that you understand your work. Anyway, guys, it is what it is. Get these questions every time you see them. So 8.7 says, consider 5x squared minus kx plus 16 is equal to this. Now, folks, this is the remainder theorem, and I showed you this in my 2005 question paper that I wrote myself. And of course, I showed you basics on how to factorize using long division. Now, this is saying where k is a constant, yeah, and q is the polynomial in terms of x. We know that it's the other factor. It's a binomial in this case when this is quadratic. Now it says we need to calculate the value of k. Now, this is suggesting, guys, that when we take our polynomial on the left and we divide it by x, this is the divisor. We divide it by x plus 2, we get this quotient. And this becomes the remainder. Now, if you think about a point on the Cartesian plane, because this is a function, so this is the point where x is minus 2 and y is 10. So again, you need to think about these things like that. That is a quadratic expression. So if there's a remainder, it means that's a point on the Cartesian plane on that graph where x is this number and the remainder is actually the corresponding y value. You can forget about the quotient. And actually, we did prove this using the remainder theorem that I showed you guys. Anyway, I hope you got it. Now, folks, what are we going to do here? Remember, this is just 4 marks. We don't need to sweat. So what are we going to do here? We're just going to say find 5x. Let's start by writing this first as it was given. So we can say 5x squared minus kx plus 16 is equal to x plus 2 times the quotient in terms of x plus 10 implies that 5, where x is minus 2 all squared minus k into minus 2 equal to 16 is going to be equal to 10. Simple. This is just 4 times 5, this is 20, plus 2k. Then we move this to this side. Okay, maybe let's not, because k is a simple number. We can just leave it. We can leave it as 16 is equal to 10. So we know that 2k is going to be equal to, this is 36. We move it to this side. 20 plus 20 plus 16, it's 36, right? We move it to this side. 36 minus 10 is 26. But now this is going to be minus 26. Therefore, k is going to be minus 13. Nice and dandy. So guys, these are easy questions. There's no issues here. We just win, okay? We just win. So it looks complex, but it's not if you understand the remainder theorem. That's why I always keep taking you back to long division when I discuss factorizations, because I need you guys to know these things, especially when we're doing the hyperbola, which is not given in the standard form, but in this other format where you've got, you know, x minus a over x minus b. That format, when you want to convert, you use long division or inspection, which is again borrowed from long division, which is nothing but the remainder theorem, factor theorem. You call it whatever you choose depending on the outcome. We say factor theorem when it gives us a remainder of 0. We say remainder theorem when we've got a particular remainder that is not equal to 0. All right. Or in general, just long division. Okay, guys, so this substitution by minus 2 is good, and the right hand side is good. I don't know where the fourth mark, guys, comes from. It's ridiculous. This is supposed to be 3 marks. There's no real reason for more than that. Okay, so that's good, guys, and we can see we got ourselves a nice constant. Okay, I've got enough space. So 8.8. Now we are told that we need to prove that x squared plus 2xy plus 2y squared cannot be negative for all y, x and y element of real numbers. Okay, this one is saying it's a level 4 question. Well, perhaps, but it's actually a level 3. But anyway, guys, what are you going to do there? Of course, start thinking. So this is x squared plus 2xy plus 2y squared. Okay? Now, another student will be like, but I could see if only I could remove the 2 there and put nothing, because then this becomes a perfect square. It's going to be x plus y into x plus y, which is nothing but x plus y squared. And so this would be greater than or equal to 0, meaning it's never going to be 0 for all real values of x. But hey, the examiner put a 2, okay? So what? Are you going to correct the examiner? I know, guys, I kind of taught you these silly things and like, yeah, make noise about it. But after making the noise, can you face it, please? Will you face it? Now, folks, I can see this is a quadratic expression. Okay? So I can decide to look at it in terms of y. I can decide to look at it in terms of x, but I study quadratics in general as ax squared plus bx plus c. So I always study my quadratics in terms of the variable x, y being the function itself. So essentially, I'm going to study this in terms of x, but even if you studied it in terms of y, you would still get it right, okay? So technically, this is what I have. Now, folks, what is the next thing? What happens when I complete the square? Remember, I always told you that if you complete a square, you will always know which direction that a quadratic expression is going, because it helps you to make a deduction, whether it's going to be positive, negative, 0, whatever. So if I complete a square here, this is equal to, now folks, I know that when I want to complete a square, I'm going to take, okay, I'm going to first write x squared plus 2xy, but this time I'm going to write it first in standard form. I'm going to say 2yx because I want x, I want this to be like that, right, plus 2y squared. Okay, that's good. So this means, I mean, we know that multiplication is commutative, so we can move it around. So this is x squared plus 2yx plus, we have the coefficient of x. So we're going to take 2y and divide it by 2. Then we square it, plus 2y squared, which was that one. Now we immediately subtract half of that coefficient of 2y all squared, right? Now remember, if you think about it, you'll be like, but what did you do, Makamba? I didn't do anything, because if you take this and this bracket, and you take this and that bracket, can you see this is the same as just adding 0? We can add 0 into an equation, but in a strategic way, so that we create a perfect trinomial that we want to factorize. So this was just as good as adding 0, but this 0 was smart. We decided to use the middle term because we know that in quadratics, when we do that, we tend to factorize nicely by completing that square. So this is the essence of it all, guys. Completing the square is nothing but adding 0 in a strategic way. So that's the principle that underscores completing the square. Now, folks, following the rules, I just went about the rules. I could have done this without doing all these silly steps, adding and subtracting. I would just do it in one go and then you'd get confused. But I'm just trying to remind you. So we take what is under the square, because remember, this is a perfect trinomial. Because technically, as much as we say we take what is under the square, and that the reason is this is technically this trinomial. We are factorizing this by grouping. So when we factorize this, we know that obviously this is just going to be 2 divided by 2 is 1. So this is y squared. Now can you see we get to that same trinomial I spoke about. Now if you write this expand, it's going to be x squared plus 2xy plus y squared. Can you see? This is what you would have wanted to correct the examiner on. And you know this is a perfect square trinomial, because we know that we literally just take the x and the sign between those two terms, and then what is the result of that, which is just going to be y. Excuse me, it's just going to be y, and then we square outside. So that's what exactly we are doing, the factorization by grouping. Since it's a perfect trinomial, that's what we're doing. And then here we just deal with this as one term. So we get 2y squared minus, this is just going to be y squared. So this is going to be x plus y all squared plus 2y squared minus y squared is y squared. Can you see now this is a perfect square? So that means no matter what x and y value we put, this is always going to be either 0 or positive. But this is also a perfect square. So whatever y value we put is always going to be positive. So now we can see that, well, by completing the square, we now learn that we can say, since x plus y all squared is greater than or equal to 0, and y squared is greater than or equal to 0, therefore the expression is always, or can never be negative. That is, the expression will never be less than 0. Can never be less than 0, or you can write in English, but sometimes do incorporate some math, because we're adding This is a sum of two squares. Sometimes you may even use that this expression will never be negative because you've got a sum of two squares. A sum of two squares can never be negative, right? Right. It's either 0 or it's positive. So folks, I hope you are learning. As I always tell, it's a, it's a devious prophecy that I hear even in your exam guidelines that, completing the square is not examinable in grade 12. Bull crap. Because look at these kinds of problems. You are likely to come across these, I promise you. And you are going to have to complete the square. You don't have a choice, okay guys? And as you can see, it's very useful to complete a square. A problem that looked impossible, you'll end up with a solution for it. Okay guys, so it's easy to make noise as I have, because you see something that is not gelling and you think it's a mistake. But sometimes try to first spot that, because there is a very good chance indeed that there is a mistake. Sometimes this is when you ask a teacher, you raise your hand, hey, invigilator or teacher, is there no mistake here? Because I can see where this thing is going. They'll be like, no, go on. But if they themselves realize there is a problem, they'll tell you, oh, okay, guys, leave that question, don't answer it. Then you know, okay, the mistake is valid. But sometimes be a true mathematician. Sometimes let even the wrong way lead somewhere. All right, I hope you guys understand. Here I was just being as elaborate as possible. For me, I would not waste my time. I would jump straight to this. So obviously we are getting 4 marks here. So I would say this is a mark. To notice this, and to make this conclusion, that would be a mark. To write my expression in turning point format or vertex format, that is a mark. And of course, now you can decide, guys, that even though we would say we are not examining this, of course, if we are saying we don't examine it, it doesn't mean though you cannot write the expression in this format. It is acceptable for grade 12 because we do parabolas in the vertex form. So this means you wouldn't get a mark for this in grade 12. So literally, if you are doing grade 12 and this question comes, you're only going to get 3 marks. But if you're in grade 11, you get this question, this would give a mark because the method is being examined in grade 11. But in grade 12, that mark we don't give. Okay. Anyway, folks, I hope this is really waking up the beast in you. That's my intention. I really want you guys to be brave. I want you guys to be excellent and to be technical sometimes, knowing how to use symbols like this, not equal to. You write, sorry, not less than. You just write less than and then you strike it like you do the equal sign. So try to get into using mathematical language, whether in notation form or in English, just plain English, okay? Try. You will be good. All right, guys, let's do the last one. So this is 8.9. So 8.9 says we need the value of this quotient. Given that 2 to the exponent 6, p is 81, and 7 to the exponent k is 729. Of course, nobody told us not to use the calculator, so we're just going to punch it nicely. So these are the 1.3 type questions, by the way. So please be aware that these questions are in that framework. Okay, let's get to business. So this is 2 to the exponent 2p minus 1 all cubed divided by the root of 7 to the k. Nice and easy. Let's first simplify. Remember, BODMAS, guys, you must get rid of brackets. So the exponents multiply. So this is 2 to the 2p minus 1 times 3. Oops. Even if we put the 3 this side, it's not a crime. All divided by, here we don't want to rush as yet because we can just leave it as what it is. So this is 7 to the k. Now we FOIL that thing out. It's going to be 2 to the 6p minus 3, all divided by root of 7 to the k. Now we can see things are taking shape. We want to use our exponential rules. 2 to the 6p times 2 to the minus 3. Can you see? Nice grade 11 question. Now this is divided by square root of 7 to the k. Now we substitute because we know what 2 to the 6p is. So this is 81 times 2 to the minus 3 divided by the square root. What is 7 to the k? 729. We know that's a perfect square of 27, isn't it? Okay, we can even just sort it out. Now here we just hoy the calculator. Unless we are told not to use the calculator, maybe we might be nice. You know, perhaps let's just pretend. This question says, do not use the damn calculator. So what are you going to do? What doest thou? Let's just say this question says without a use of a calculator. Because in the NBT, you might get such a thing. Okay, let's say there's an additional statement and you're in the NBT exam, which you guys need to get ready because NBT has higher grade algebra or function questions. Everything you get in the NBT is of the higher grade format. Yes, there may be some basic questions because they're always there so that you don't fail. We don't want a 0, it's an embarrassment. So to protect ourselves to having students who literally do maths but don't know it. Right, let's not do the things. Now let's go on, folks. This is going to be equal to. Now let's just leave 81 for now because we want to concentrate on the square root so that we can get a bit of direction. Now in maths, you delay certain steps for later. As I said, you don't tell until you find out fully what's going on. Even then, you still decide, is it worth it or is it not? Now folks, 729, we know that this is 27 times 27. So 729 is 27 squared. If you don't know, cheat a bit. But of course, in the NBT, you won't have the calculator. So you might as well know these perfect squares, guys. I mean, there's no excuse. I mean, there is no excuse, guys. Anything less than 1,000, you should know by head. If you don't know it by head or by heart, you are not doing maths. You are just bluffing. So this is 81 times 2 to the exponent 3 divided by, we convert to exponential form, 27 squared. Now it's a rational exponent that we get. So this is 81 times 2 to the 3 all divided by. Now we know that this dude takes care of the dude, so we only get 27. But now is 81 a multiple of 27? Yes, it's 27 by 3, right? Of course, at this point I'm going to cheat. Yes, this is 3 times 27 times 2 to the exponent 3 all over 27. And yes, it's getting there. And now what do we have, guys? We've got 3 over 8. Nice and easy. There's nothing we can do about that. So that is essentially, folks, what we come down to. So please, folks, know your craft, know your work. There's no excuse. As you can see, we can easily make it hard for you by saying don't use a calculator, meaning we want to see all those steps. Of course, you can cheat your way in the standard exams, but in the NBT, if you get this question, you are going to fail if you don't know the perfect squares up to 1,000. You might as well learn them. The perfect cubes up to 1,000, you need to know them at least up to 1,000. That much we expect from you. but push yourselves to the limit. Maybe push yourself to the tens of thousands. Because let me ask you guys, what do you do when you've got a free period? Maybe it was a maths period. Now your teacher is not there. What do? You sit there and talk about TikTok and all the nonsense in the villages and townships and whatever, wherever you stay, TV, you name them. Or do you sit there and challenge yourselves with numbers? Because that's what we did. We would sit there as a group of 4, 5 while others are busy talking trash and minding things they're not supposed to mind. We would sit there and challenge ourselves by just writing out the perfect squares. Then if the other guy succeeded, we give the question to the next guy. He has to write out the perfect cubes. We keep playing, guys, playing with composite numbers, just simple tricks, getting yourselves into an easy mode of doing maths. And eventually you become something that looks like, a computer. Anyway, folks, that's not cool. Let's not talk too much. So that was important, folks. Here, when we substitute, I think it's key. And when we actually finally substitute over there, actually not here. But let's just see which step is critical. Is the step, right? Substitution, answer. Now let's see how many marks. 4. Wow, this is not right. Dang. But anyway, guys, whatever it is that you can think of, but now it looks like we can't give substitutions too much. They are too simple. You can say substitution and perhaps this one, because you have not been using a calculator. That's fair enough. But anyway, guys, this is it for today. Or is it tonight? Or is it this morning? This is it for this morning, folks. And I hope this makes up for the time we lost during class, because I want us to keep going over these questions, knowing that I've given you a nice short course on some higher grade algebra on that long, lengthy video. Yes, that one. You saw it. Please go and watch that video. And don't just watch it, learn from it. Even redo those questions, because I put on the description of that video those questions. After watching that video, I would suggest don't watch or anything related to it. You can watch it from start to finish, then you stop. You do other things. You let perhaps a week pass, or maybe let's say minimum 3 days. You let 3 days pass. After that, you take that worksheet, you sit down with it. Now, what I expect you to do is to make it a challenge so that it's not too easy. You sit down, you time yourself. Okay? Time yourself. Make it a bit strenuous. Say, since I did that video in about 3 hours or so, time yourself for 2 hours and see if you can take it down. And in each step, you're trying to be as elaborate as possible. Then when you get stuck, you leave those ones that cause you to get stuck. After doing that, you check how many did you get right. The ones that you didn't get right, you then sit down with them. Don't look up the solutions. You sit down with those questions. You then don't give yourself a time limit. You just solve until you get it right. After that, you come back to the video and see what was missing in your attack. What did you forget that you should not forget? That way, guys, you're going to become as good as you wish to be. And you're going to be as good as we hope you to be. Anyway, folks, I hope you enjoyed the video. Give it a thumbs up. At least do that. And if you feel this is worthy of seeing the eyes of your good friends, you can share it with them. And of course, you can rewatch. You may even consider subscribing if you're new to this channel. Here we don't bite, but we teach. Okay, we teach. Anyway, guys, see you in class tonight, 7:30 evening. We are going to carry on. I hope everything is well. For those who are writing, good luck. Anyway, by the time you see this video, it will be already in the afternoon today, because I'm going to let it come out at 3 in the afternoon. So by the time you see it, even this type I'm talking about will have passed a bit, isn't it? Because it's a 1 hour, some 19 minutes video. So yep. Anyway, folks, if you've got any questions, ask me. If you've got any issues, you let me know. Either way, I didn't use any fancy university techniques here. It was purely high school level mathematics. Anyway, folks, I think it's too long, this video. Let me cut it here. Let me leave and love you. And as I said, don't be late. 7:30 tonight, we are going to tackle maths. As for the physics, the time we lost, I tried to make up by doing that video for KZN March 2026. I did a full video so that you can just go and catch up. But we're going to still handle physics Saturday, maybe Sunday as well, so that those who are writing next week the physics, they can go and kill it. Anyway, guys, goodbye.